gentlemen.
Good morning.
Good morning.
Good morning. Good morning. Good morning.
I hear that the instructor's really good.
Ladies and gentlemen, for the formal introduction, for those of you who don't know, my name is Bill Sholz, W1HIJ. And duplex is now used to mean, in most cases, now used to mean repeaters. But that's not what it actually means. What it actually means is two frequencies. The only fully capable, competent, satisfied satellite contact I've ever had was in probably 1995 or 6. Uplink on 10 meters, downlink. Uplink on 2 meters, downlink on 10. So they could be that. So that's what duplex means as opposed to simplex. In FT8, the actual signal is so narrow that in the normal, say, 3 kilohertz wide bandwidth, you can have 15 or 20 different signals. And they're all individually selectable. So on VHF, the offset is 0.6 megahertz, 600 kilohertz.
Can they do?
Cavities is another one of those words that everybody knows. Oh yeah, okay, cavities. No, like teeth? No, not that kind of cavity. They're very narrow, very sharp filters. A normal voice signal, which gets processed and digitized, and then transmitted as a digital signal, and then detranslated, so to speak, at the other end, and brought back to voice so that you as a human being can understand it.
Like a modem.
Yeah, that's exactly what it is. It's a modem. Instead of taking even an analog signal, digitizing it, transmitting it over the air, and then decrypting it, decoding it on the other end, instead of doing just that, you take the analog signal, you encode it, and you send it to the internet. The internet now sends it to Australia or wherever you tell it to go. And there, it does the reverse. There, it comes out of the internet into a box which will decode it and convert it into something that you as a human being can understand. Called PSK 31. They are keyboard-to-keyboard modes. They're not fast particularly, but they're as fast as usually most people can type, so it doesn't matter. What's really, really popular is this mode that's called FT8. And FT8, Fox Tango 8, was invented by a guy who's actually a Nobel Prize winner in physics. Joe Taylor's his name, and FT8 is a mode that is incredibly accurate in terms of extracting information from very poor conditions. If you listen carefully, they're 15-second cycles. One group of stations transmits for 15 seconds. They stop. The other group of stations transmits is like a 1 or 2 second pause. The other group transmits the next 15 seconds. They alternate back and forth. I mean, how far away and at what time of day or night, right? Those two things control a lot of what you need for an antenna. What you can then do is a different issue. What do you have for a transceiver? There are two big issues with the transceiver, in my experience here. One of them is the power level, meaning, it's really cool to have something that you can carry around in your shirt pocket, but 5 watts will only get you so far. So you've got to think about what kind of power level do I want to have available to me. Not necessarily I'm going to use it all the time, but I want it to be available. That's one issue. Second issue is bells and whistles. And what I'm finding is that even though I've got a lot of experience and I've done this for a lot of years, it's still taking me quite a while to get to the point where I really can effectively use what that radio can do. If you're going to have an effective station there's a certain level of accessory tools, I'll call them, you really need to have. Because you're going to run into issues which, if you have the accessories, they're great. If you don't have them, you can still solve the problem, but it's going to take you a lot longer, and it's going to be a lot, perhaps, less accurate. So, perfect example is something that didn't even exist 20 years ago, and that is what is now referred to as an antenna analyzer. Many antennas require a what's commonly referred to as a ground plane. A ground plane means something that will allow you to create a virtual other half to your antenna, because your antenna as it exists is actually only half an antenna. And now you need to make it have a second half, and it's virtual, it's not real. And that's done with RF grounding. When we talk real estate, we talk the most important thing is location, location, location. When we talk ham radio, the most important one is antenna, antenna, antenna. Okay? There are two, well, let me put it this way. The way I've always said it is, if you have $1,000 to spend on a ham radio station, spend 750 of it on the antenna. And then the other 250 you spend on whatever else you need to have. Because the best radio in the world is an electronic paperweight unless it's hooked to a good antenna. It's as simple as that. Resonance is related to the frequency at which the antenna, whatever it is the most effective as a radiator. And the third parameter is what's called SWR, or standing wave ratio, or its real name is voltage standing wave ratio. Real name is VSWR. That's become the standard that everybody measures against. The problem is that there's two elements that control SWR. Guess what they are? Resonance and impedance, okay? And they controlled it in opposite directions. So I can have a mismatch, so to speak, in resonance, the frequency that I want to use versus the frequency the antenna is best at, and another mismatch in impedance. And if I pick the right numbers and the right signs, I can get them to cancel each other out. And now it looks like I have a very good system because the SWR is minimum. I can't do 65 feet. What do? Well, there's lots of alternatives. I can put up an antenna in an inverted V fashion, which means I have a single support in the center and the wires come down this way. So now this space is not 65 feet anymore. Maybe it's 50, and I have 50. Okay, so I can do that, as long as I can go up, right? That's one kind of compromise. It has several disadvantages and a couple of big advantages. The advantages are the low loss. The disadvantages are it's ugly as sin. And the other one is that when it rains, it changes because you get water in here. And so it's not 450 ohms anymore, it's something else. And who knows what, but the point is it's something else. So underneath my radio room, I have three 3-foot ground rods driven in a triangle. And I bond the three of them together, go from that to the bus bar, and I ground everything to the bus bar. Vertical antenna, classic vertical antenna, right? 7 megahertz, 33 feet long, vertical, okay? It's a quarter wave. You feed it at the bottom, and that means that you're actually feeding a half-wave antenna, but the half-wave's not there. So what do? Well, one thing you can do is you can take a half-wave length of wire and lay it on the ground. Now you got another quarter wave. So now you're feeding a half wave, not a quarter wave. Or you can just make the ground, fit the dirt around the base of the antenna be more conductive. And if it's more conductive, it will let you use it like a mirror. So when you put power into that vertical that goes up, you're creating a vertical that goes down. And it's virtual. But it works the same, so who cares? Because what happens is you get a consistent wind blowing for a long time, it builds up a static charge. That static charge has to go somewhere. And it's probably going to go where you don't want it to go. But it's going to go somewhere, no matter what. Transceivers, I'm talking new prices now, is huge. From significantly less than $1,000 up to $12,000, right? That's probably more than you want to deal with. But there's a huge gap, a huge difference. And so the question is, well, okay, if there's that big a difference, what am I really getting? Or what might I get? Right? So the first group, is what I call entry level. It's basically a capable receiver that addresses all the modes, single sideband, CW, AM, FM, over a frequency range of about 2 to 30 megahertz or 2 to 54. So they either include 6 meters or not. But that's basically the difference. Right? They have basic capabilities to deal with interference or noise. And you'll see in a minute what I mean when I say basic versus something else. And there may be some limited capability of dealing with those issues, interference and noise, digitally as opposed to in an analog fashion. Okay? As time goes on, that digital capability is being pushed down in price because it's getting cheaper and cheaper to implement. So more and more of the lower end levels, the bottom category, so to speak, is having some of that. Okay, so that's the entry level. Those radios new sell for, call it 700 up to maybe 1,500, something like that. Second one is, I call it professional, for lack of a better word. Essentially all of the upgrades here that move you from entry to professional deal with the mitigation or reduction of interference and noise. Occasionally there'll be some where you get additional bands, but it's nowhere near as common as it was even 5 years ago. 5 years ago, there were 3 or 4 or 5 radios in the market that did all of HF plus all of VHF plus all of UHF. There's now 2. So those big all-band, all-mode radios are becoming new or becoming less and less common. As I said, all of the upgrades here pretty much going to deal with interference, mitigation, and reduction, and it is all done through, almost always, not entirely, but almost always done through digital signal processing, which is a tremendous advantage. It's relatively cheap, and it has an incredible amount of flexibility. Then there's the very top one, which I don't have a name for. It's the top of the line stuff. It's all bells and whistles. We're talking about radios that cost anywhere from $7,000 to $15,000. Okay. They will be things, we don't have one out here now. We have had them in the past, which is an ICOM radio that sells now in its current version for just under $14,000. It's essentially 2 complete radios in the same box. It's complete transmitter, complete receiver. So it lets you do all kinds of things that you couldn't do otherwise. That's one. The other is they have a ton of bells and whistles. Instead of 2 antenna inputs or outputs, they'll have 4. instead of sort of kludged together arrangement to use a separate receiving antenna, they'll have a whole separate circuitry for that and things like that. They go to the very top, right? So that's the very top. There aren't very many of them. There are, let's see, 1, 2, probably 3 or maybe 4 that I can think of.